hello. So what I have here is a air balloon suspended inside an aquarium. Okay, so there's air here, and then we have a balloon which is housing air. And the balloon with its air in is more dense than the surrounding air that is in the aquarium. So if I accelerate the aquarium to your right, okay, because the surrounding air is less massive than the balloon with its enclosed air, you'll find that that undergoes a greater acceleration in the balloon. Therefore, the balloon will go back. Okay, so you saw that the balloon went to your left when I accelerated the aquarium to the right. Okay. What I'm going to do next is I'm going to replace this balloon with a helium balloon. Now keep in mind, this is a demonstration of Newton's second law, which says that the acceleration is in the same direction as the net force, but there's a mass factor there, right? The greater the mass for a given net force, the lower the acceleration. So what I'm going to do is I'm going to replace the balloon with a helium balloon, and the helium balloon is going to have it's going to be less dense than the surrounding air. So we should have the opposite effect. So I'm going to fill this with helium. All right, so now I have the helium balloon in the aquarium, and the helium balloon is less dense, okay, so less massive per unit volume than the surrounding air. So if I accelerate to the right from Newton's second law, the balloon, the red balloon in there, should have a greater acceleration than the surrounding air. Okay, so let's take a look at that. And that means that it should go forward when I accelerate. Okay, here I drew a sketch of a person. You can see his brain there. And this blue region here is his spinal fluid. And that's analogous to the air in the aquarium. And the brain is analogous to the helium balloon, because it turns out that the brain is actually less dense, less massive per unit volume than the spinal fluid. So if, let's say you're running and you hit a brick wall, okay, that brick wall is going to exert a force to the right. Since the brain is less massive per unit volume than the surrounding spinal fluid, the brain will actually hit the back of the skull in a frontal collision. So the brain damage will be more severe in the back of the brain in a frontal collision.
Happy holidays!